company Handley Page, following the personal convictions of its founder, in the mid-30s specialized in the design and manufacture of large bombers. This continued the work it had done during the First World War, when the company produced a famous bomber known as the Bloody Paralyzer and an even larger aircraft. After the war, the company continued its activities and delivered several biplane bombers to the Royal Air Force. In the early 30s, the company set about creating a medium day and night bomber, and then another aircraft that was ordered as a stopgap fit for the rapidly expanding British bomber force. However, by the outbreak of the war, it was no longer used as a bomber. The next step for Handley Page, and the first stage on the road to creating the Halifax, was the specification issued in the spring of 1935. It required the creation of a heavy, twin-engined bomber, mainly for night operations, intended to replace the recently introduced Whitley. Ultimately, the specification demanded an aircraft able to carry a maximum bomb load of 4,000 pounds for a maximum range of 2,000 miles at half load and at an economical cruising speed, and no less than 1,500 miles at a higher speed of 195 miles per hour at an altitude of 15,000 feet. There was also the customary restriction of the time on wingspan, 100 feet, so that the bomber would fit into existing hangars and could be dismantled into sections for easier transport. The choice of engines lay between several options, each rated at approximately 1,000 horsepower. The specification was issued by the Ministry of Aviation on May 8, 1935. Of those who received it, 4 companies responded. The proposal from the first was rejected at once, and prototypes were ordered from the other 3. One of those was later canceled while it was already under construction, and another appeared as an aircraft that was never actually employed as a bomber. Handley Page's design was a monoplane with a low-set wing and a maximum weight of 25,000 pounds, which recalled the company's earlier designs. It was finally ordered on October 23, 1935, armed with single machine guns in the nose and dorsal turrets and 2 machine guns in the rear turret. With the pair of chosen engines, the aircraft's speed was estimated at 251 miles per hour, but its range with maximum bomb load did not fully meet the specification. The performance with other engines was less encouraging till a new engine variant appeared in May 1936. However, even with those engines, or with yet more powerful ones, the aircraft proved insufficiently capable for the planned role. Increasing the fuel load to achieve the required range would only increase the weight further, and performance would fall again. By September 1936, the prospects for this aircraft were poor, and the greatest hope of meeting the requirements lay in postponing development until a new generation of more powerful engines of 1,700 horsepower became available. That same month, Handley Page were told of the Air Ministry's interest in an even larger and heavier twin-engine bomber. Although the maximum weight was envisaged as approximately twice as great, the new type was considered a medium bomber since the term heavy was being reserved for 4-engined aircraft. The command's conception of the future of bombers had undergone a sharp change in the space of a single year. The short bomber was practically the only aircraft created according to specification B 12/36. Interestingly, the Handley Page Halifax, which eventually replaced the Sterling, was initially developed as a medium bomber, with the advantage of a catapult-assisted takeoff concept based on research by the Royal Aeronautical Institute. Specification P13/36 called for the ability to carry a bomb load of 8,000 pounds, twice the maximum allowed under specification B1/35, to a range of 2,000 miles. However, the limitation on wingspan remained unchanged. The company understood that if engines of the required power could be obtained, the HP-55 design could be adapted to the P13/36 specification, which thus replaced B1/35. This viewpoint was presented to the Air Force Command by the end of September 1936, and at the beginning of 1937, detailed plans for the HP-56, created by Walkert's team based on HP-55, were proposed to meet the new requirements. Similar in general layout to the HP-55, the new project featured a wing raised to a mid-position to create a continuous bomb bay. It was designed to carry 16 bombs of 500 pounds each, or 4 armor-piercing bombs of 2,000 pounds each, or 2 torpedoes 18 feet long. Bombs of 1,000 pounds were not yet in Royal Air Force service in 1937. The Rolls-Royce Vulture, essentially two Kestrel engines mounted on a shared crankshaft forming an X-shaped configuration with 4 rows of cylinders, was included in specification INDP 13/36 despite its immaturity and represented a certain technical risk. This engine was shown as the main power plant in the HP-56 project in March 1937. The Napier Sabre, with a projected output of 2,000 horsepower, was considered a possible alternative. The additional power of the Vulture, combined with the relaxed takeoff requirements when not using a catapult, allowed Handley Page to increase the wing loading of the HP-56 to 30 pounds per square foot under normal load, compared to 25 pounds per square foot on the HP-55, and in the overloaded version up to 40 pounds per square foot or more. These loadings were calculated for a smaller wing area than originally planned, and the HP-56 emerged with a wingspan of 88 feet, compared to 95 feet for the HP-55. This reduction helped decrease structural weight and provided greater potential for combat loads, which, in addition to bombs, included a nose and tail turret with 2 and 4 machine guns respectively. The HP-56 was designed for a crew of 4 men, 2 pilots, one of whom also served as navigator, bombardier, and front gunner, plus a radio operator and rear gunner. Accommodation was also provided for 2 additional crew members. The aircraft was intended to carry a very wide range of military equipment, allowing it to operate worldwide, day or night, sometimes as a reconnaissance or transport plane. Archaically, specification P13/36 actually required the installation of a mail pickup hook and racks for small bombs, features of biplane bombers of the 1920s, which were entirely irrelevant for the high-speed monoplanes of the late 30s. These requirements were soon discarded, but instead the Air Ministry demanded the ability to perform dive bombing attacks at angles of 30 degrees. To meet this requirement, Handley Page fitted large-span slotted flaps on the wing. They were later replaced by split flaps deflecting 60 degrees to shorten the landing run after dive bombing was abandoned. On the last day of April 1937, the Handley Page Company received an order for 2 prototypes of the new aircraft. Work on this project, which had been suspended in September of the previous year, was officially closed on January 23rd. The company was concerned about problems with the Vulture engines and wanted to assemble the first prototype with Hercules engines to begin flight testing as soon as possible. However, the contract required Vulture engines to be installed on both aircraft. In mid-July 1937, personnel from the Air Ministry visited the factory in Cricklewood, where a full-scale mock-up of the new aircraft was under construction. They suggested that Handley Page explore the possibility of using alternative engines. Instead of the 2 Hercules units, the company considered installing 4 engines: Bristol Pegasus, Bristol Taurus, Napier Dagger, or Rolls-Royce Kestrel. Yet none of these options seemed attractive. Any pair of those engines would have weighed more and required more fuel and oil than a single Vulture. At the same time, they did not provide enough additional power to offset the extra weight and the aerodynamic drag from 2 additional engine nacelles. From these studies, conducted during July and August 1937, came the proposal to replace the 2 Vultures with 4 Merlins. This immediately appeared so promising that, on September 3, 1937, the Air Ministry amended the contract, ordering a prototype fitted with this new power plant. Still, part of the company's staff agreed to it reluctantly. The project at the Cricklewood Design Bureau was renamed. With 4 engines, the wingspan increased to 101 feet, slightly above the hangar limit. The increase was necessary to accommodate the outer engine nacelles and keep the wing loading within acceptable limits at the new total weight of 46,970 pounds. Before the prototype was ready to fly, the weight had risen further, reaching 48,970 pounds. However, the power of 4 Merlin 10th Series engines, each rated at 1,010 horsepower at an altitude of 17,750 feet, housed in narrow nacelles with relatively low drag, proved sufficient to raise performance to the level demanded by the specification. In accordance with what was then standard practice, production plans for the new aircraft were outlined starting from the prototype's first flight. The initial expansion plan for the Royal Air Force, known as Scheme C, dated from May 1935, and had produced a series of transitional aircraft while more capable machines were being developed. In 1936, it was replaced by Scheme F, which emphasized the planned production of the newest models. This aircraft, given the name Halifax, previously abandoned in favor of another design, was the first to be ordered under Scheme F. That scheme formally covered aircraft to be delivered to the Royal Air Force from March 31, 1939 onward. The order for the first 100 Halifax bombers was placed only on January 1, 1938. Naturally, the idea of completing deliveries within 15 months was entirely unrealistic. A more achievable goal appeared in Scheme K, issued in April 1938, which envisioned assembling 250 Halifaxes by April 1942. By the end of that year, the Munich crisis led to Scheme L, which doubled the number of Handley Page bombers to be produced within the same period. It also called for building 1,500 Avro Manchesters and 1,500 short Stirlings. This, in turn, required the creation of additional manufacturing facilities and assembly lines, as Handley Page alone could not achieve the necessary output. Before Scheme L could be completed, the nation was already at war, and other factors began to determine both the number of Halifaxes produced and who would build them. In March 1939, construction of 2 experimental prototypes began at Cricklewood. While these aircraft were being hand-built in the experimental workshop, plans appeared to simultaneously create tools and equipment for mass production. The manufacturing process was based on the principles of assembly from separate sections and the broad involvement of subcontractors, using the company's innovative developments in the field of component interchangeability. Initially, it was planned to install Fraser-Nash turrets, one at the rear and one at the front. But those plans changed. It turned out that there were not enough of these turrets for both bomber types, the Halifax and the Manchester. The design had to be modified slightly to fit Boulton-Paul turrets. Along the leading edge of the wing, from the very tips to the outer engine nacelles, automatic leading-edge slats were installed, a technology with which Handley Page had extensive experience. However, flight tests showed that it was better to increase the maximum deflection angle of the flaps, as that more effectively improved takeoff and landing performance. The leading edge of the wing was also needed to mount the cutters used against barrage balloon cables. In fact, the slats were installed only on the first 75 production Halifaxes, and even on those, they were locked in a fixed position. For the first flight, the prototype was transported in parts from Cricklewood to Bicester Air Base, where the 13th Training Unit was stationed. The runway there was longer than at the company's Redlet Aerodrome and provided better secrecy. On October 25, 1939, the aircraft was flown by the company's chief test pilot, Major James Cordes, together with observer Edward Arthur Wright. At the last minute, the Lockheed hydraulic brakes were replaced with Dunlop pneumatic ones, since Cordes had found the former unsatisfactory during earlier taxi tests. The introduction of detachable protected fuel tanks instead of built-in ones in the center and outer wing sections, intended to simplify production and maintenance, was postponed until the start of serial production. The first prototype had streamlined fairings instead of nose and tail turrets. It was equipped with 2-position, 3-bladed de Havilland propellers. Later, in 1940, dual controls were installed, and it was used for crew training when the first squadron began to master this type of aircraft. Before that, it had served at the Boscombe Down Research Center in 1939 for preliminary controllability tests and in 1940 for flight performance measurements. Its full weight was about 50,000 pounds. The second prototype, which took off on August 17, 1940, had a Boulton-Paul nose turret with 2 machine guns and a tail turret with 4. It was equipped with wooden, 4-bladed constant-speed Rotol propellers, the same as on the first production aircraft. It also featured dual controls, anticipating its later use as a trainer after test flights at the research center. The production standard was defined by the technical specification. The first aircraft to roll off the assembly line at Redlet took to the air on October 11, 1940. The maximum takeoff weight had again increased to approximately 55,000 pounds after several necessary design changes. Since the maximum landing weight turned out to be about 50,000 pounds, an emergency fuel dumping system from the wing tanks was introduced in case a landing had to be made immediately after takeoff. These aircraft were notable for 3 external tubes under the wing between the engines. The bomb bay, arranged for about 8,000 pounds when carrying bombs of 502,000 pounds, was supplemented by bays in the center section of the wing where a further 6 500-pound bombs could be carried. Later, the maximum load rose to approximately 13,000 pounds. The main fuel capacity in the early aircraft amounted to about 1,670 gallons in 3 tanks between the engines of each wing, and 1 tank in the leading edge between the engines and the fuselage on each side. 2 tanks of 96 gallons could be fitted in the crew rest compartments, and 1, 2, or 3 tanks of 276 gallons could be placed in the bomb bay, reducing the bomb load. From the initial contract for 100 Halifax bombers signed with the parent company, 84 aircraft were delivered as the first type in 3 different batches. The first 50 machines, known as the first series of the first type, were followed by 25 aircraft of the second series. In these, the all-up weight increased to 59,990 pounds without a change in the landing weight, and a side defensive armament appeared in the form of a pair of Vickers K machine guns on each side. They were mounted back-to-back and fired through hatches in the fuselage sides. Beginning with the 76th aircraft, modifications to the power plant were successfully introduced. Enlarged oil radiators allowed the use of Merlin XX engines. 2 tanks of 96 gallons were removed from the fuselage, and 2 additional tanks of 147 gallons were installed in the wing behind the outer engine nacelles. In this form, 9 aircraft with Merlin X engines were built as the 3rd series of the first type, until Merlin XX engines became available. With the new engines, beginning with the 85th aircraft, machines were produced as the first series of the second type. They also differed by having a Boulton-Paul upper turret of Type C with 2 7.69mm guns instead of 4 side guns, and by having 2 further wing fuel tanks of 148 gallons each. This brought the total normal fuel capacity to 2,260 gallons plus the additional tanks in the bomb bay. Halifaxes of the second type began to appear in September 1941, but 1 aircraft of the first type of the first series with the extra fuel capacity and Merlin XX engines flew as a prototype of the second type on July 3, 1941. Compared with the Merlin X, which produced 1,075 horsepower, the Merlin XX had 1,280 horsepower. At the rated height of 21,000 feet, it developed 1,175 horsepower compared with the Merlin X producing 1,010 horsepower at a height of 17,750 feet. A Type C2 upper turret was fitted, which had first been trialed on a first series aircraft of the first type that was used in the aeroplane experimental section for armament work, together with a lower turret mounting 2 machine guns. The retractable Boulton-Paul lower turret Type K1, designed specially for Halifax, was not actually fitted. In production, the Halifax of the second type received a designation at Handley Page. Another designation was intended for a planned, more heavily modified bomber variant, known during development in the early months of 1939 as the Halifax of the second type. Doubts about the ability of the new generation of heavy bombers, including Halifax, to protect themselves against fighters during daytime operations led Handley Page to propose to the Air Ministry a more powerfully armed variant. It was to have 2 Boulton-Paul turrets, an upper Type N and a lower Type O, each with a pair of 20mm guns, and a new rear fuselage with reduced aerodynamic resistance and no tail turret. In July 1939, the contract was amended to convert the first prototype into the new variant. It had been planned to switch production from the 11th aircraft to the Halifax of the second type, but delays in finalizing the gun turrets upset this plan, and the Halifax of the second type appeared with the more modest armament described above. Production of the Halifax progressed more slowly than expected during the early planning stages. Despite the efforts made by Handley Page to simplify the manufacturing process and divide the airframe into units that were fully prepared for final assembly. This approach proved to be a blessing when other manufacturers joined the Halifax production program, as will be described later. Initially, however, operational use of the Halifax depended entirely on deliveries of the first variant by the parent company. While introducing the new bomber into service, Bomber Command reformed the 35th Squadron on the 5th of November 1940. Temporarily stationing it at the Aeroplane and Armament Experimental Establishment in Boscombe Down to take advantage of the experience gained there with prototypes and early production aircraft. The first Halifax assigned to this squadron was a Mark I aircraft that arrived at Boscombe Down on the 13th of November. However, by the time the 35th Squadron moved to Linton-on-Ouse in December and received 2 additional aircraft in January, progress had been limited. By the end of February, there were 7 aircraft at Linton, plus the first prototype used for training. On the night of the 10th of March, 6 of them were sent on their first combat mission. Late that evening, they attacked the docks and canal in the French port of Le Havre. 4 Halifax bombers located the main target and released their bombs, and all 6 returned to England. Tragically, one was shot down over Surrey by a British fighter, a grim example of the many losses caused during the war by friendly fire and misidentification. During March, they carried out several more combat sorties, but the main focus remained on training, which intensified in April following the formation of a second unit, the 76th Squadron. During this period, numerous problems emerged, particularly the unreliability of the hydraulic system, which caused difficulties with the landing gear and led to all flights being suspended in May. By mid-June, both squadrons resumed operations as part of No. 4 Group, where the Halifax replaced the older Whitley as the primary bomber. The frequency of operations steadily increased, with most missions carried out at night against targets in German ports. On the 24th of July, 1941, the 2 squadrons contributed 15 Halifax bombers to the daylight attack on the German battleship Scharnhorst, anchored in the French port of La Pallice. 5 aircraft were lost and 7 others were damaged. Similarly, heavy losses occurred on the 30th of June, when 2 of the 6 Halifaxes sent on a daytime raid over Kiel were shot down. After that, no more daylight raids were undertaken for the next 6 months. During that time, another unit, the 10th Squadron ASH, was formed, along with a special conversion unit, the 28th Conversion Flight, later redesignated as the 1658th Heavy Conversion Unit, at Rickhall, dedicated to training new Halifax crews. Formed in October 1941, the 10th Squadron was equipped mainly with the new Halifax Series 2, the first of which flew from Radlett in September and from Samlesbury on the 15th of August. The latter was the first Halifax bomber built under subcontract by English Electric, which had received an order for 200 aircraft on the 30th of April 1940. As early as February 1939, English Electric had been instructed to prepare for a transition from producing the Hampton bomber to the Halifax. From the outset, the company manufactured the Series 2 version, ultimately delivering 900 aircraft while Handley Page produced 615. The increase in Halifax output, which began in January 1942, gained additional momentum when the London Aircraft Production Group joined the program. This organization, with a final assembly line at Leavesden, drew upon the manufacturing facilities of the London Passenger Transport Board, Park Royal Coach Works, Express Motor and Body Works, Chrysler Motors, and Duplex Bodies and Motors. Together, they produced 450 Halifax Series 2 bombers before transitioning, along with Handley Page and English Electric, to later variants powered by Hercules engines, which will be described later. 2 other organizations produced variants of the Halifax bomber equipped with Merlin engines. Of these, only one, Roots Securities Limited, located at Speke near Liverpool, manufactured the second modification, building just 12 aircraft, one of which was lost during flight testing before acceptance. In total, Roots had an order for 670 aircraft of the second series, but a shortage of Messier undercarriages combined with reliability issues led to the introduction of a new landing gear system on the remaining 658 aircraft under the Roots contract and on 246 Merlin-powered Halifaxes assigned to Ferry Aviation's Stockport factory. This upgrade resulted in the creation of the 5th series. This new mark featured the installation of Dowty hydraulic landing gear, along with a revised hydraulic system that used DTD-44 mineral-based fluid, which was incompatible with the castor oil-based system used on Messier-equipped Halifaxes. Although the Dowty gear was not identical in appearance, it required no structural changes to the airframe connections. Only the altered hydraulic system made this version non-interchangeable with the second series in terms of servicing and supply. For that reason, a new series number was introduced and Handley Page assigned its own designation to it. The Mark V proved prone to failures in its cast landing gear components. These were introduced to replace stronger forged parts in order to speed up production. Because of this, the landing weight was limited to 40,000 pounds, reducing the attractiveness of the Mark V as a bomber. Consequently, it was used mainly in other roles. Many Halifax Mark V aircraft were fitted with 4-bladed Rotol propellers. They underwent the same modifications as the Mark II, leading to the creation of the Series 1.1 Special and the Series 1A, which will be discussed later. The first Halifax Mark V, built by Fairey, made its maiden flight on October 27th. Parts for the 5 final assembly lines arrived from several hundred suppliers across the country. Production of the Halifax was in full swing. In January 1943, output reached 137 aircraft per month, while the main company also hit its peak with 35 bombers per month. For all the companies building the Halifax, the production peak came the following year, an average of 208 aircraft per month during the first 6 months of 1944. In 1942, one Halifax Mark V was flown to Canada as a sample for Canadian Associated Aircraft, which had just completed the production of Hampton bombers. However, Canadian production proved unfeasible once the shortcomings of the Dougherty cast undercarriage became clear. As a result, production of such landing gear, and with it the Halifax Mark V, was discontinued in Britain at the beginning of 1943. From 1942 onward, the formation of new Halifax units accelerated. The 4th unit to operate this type was No. 102 Squadron, formed early that year. By this time, all squadrons had received new aircraft equipped with the TR-335 radio navigation system known as G. In December 1941, the first 3 squadrons again took part in a daylight raid against the German ships Scharnhorst and Gneisenau in the French port of Brest. The raid ended with inconclusive results. Early the next year, 9 Halifax bombers from No. 10 and No. 76 squadrons made an unsuccessful attempt to locate the German battleship Tirpitz in a Norwegian fjord. The main attack on Tirpitz took place in March. 6 out of 34 Halifax aircraft were lost, mostly because they were operating at the limit of their range, even though each carried only 2 mines weighing 1,000 pounds apiece. 2 further raids on Tirpitz were organized in April, but success continued to elude the Halifax squadrons. In April 1942, the 76th Squadron became the first Halifax unit to use in combat the new British 8,000 pounds bomb. This occurred during a raid on the German city of Essen. Bombs weighing no more than 4,000 pounds were joined in tandem. Their carriage on Halifax, as well as the carriage of 2 separate smaller bombs, was possible only with modified bomb bay doors, which when loaded did not close completely. One of the first aircraft of the 76th Squadron, a Halifax II Series 1, was later used for experiments. Squadron markings were then replaced by the letter P. A 4-gun upper turret Bristol B-12 Mk1 with low aerodynamic drag was tested on it. By the end of May 1942, 2 Halifax bomber squadrons were ready for operations. They took part in the first mass raid of 1,000 bombers on the German city of Cologne. 118 aircraft of this type participated in that operation, and only 4 of them did not return to base. In June, similar mass strikes were carried out against the cities of Essen and Bremen. This style of bombing operations became the standard both for Halifax aircraft and for Bomber Command as a whole. One squadron flew these aircraft for a time, but was later re-equipped with another bomber type, Lancasters. This was part of a policy of standardization, aiming to have units within a group operate the same aircraft type. In addition to the original 4th Group, in 1942, Halifaxes began to be delivered to squadrons of the 6th Group, manned by Canadian pilots and crews. The 1st Canadian Squadron received these bombers, and in October 1942 another followed, being the first to introduce a new modification of this aircraft into combat. Other Canadian units flew later versions of the Halifax with more powerful engines, as did 2 French units and 1 Australian unit. In July 1942, Halifax bombers became the first and only British 4-engine aircraft sent to the Middle East and to North Africa. This happened when a force of 16 aircraft from 2 squadrons flew to Akir in Palestine, forming a wing that supported Allied defensive forces. Their first operational sortie was flown on the night of July 11 to July 12 against the city of Tobruk. From then on, the city became a nightly target, despite the fact that Halifax aircraft were not adapted to desert operations and had low combat effectiveness in such conditions. These units combined to form an Australian squadron manned by Australian crews. That unit continued to operate actively in the Middle East and in Italy until March 1945. In March 1944, it was reoriented from its original role to target marking missions using Halifaxes fitted with radar. By that time, the squadron number had changed since another squadron with the same number was being formed in Great Britain, although the unit remained predominantly Australian. Between May and September 1943, another squadron also took part in operations in the Middle East. At the end of the summer of 1942, one of the pioneering Halifax squadrons became one of 5 that formed the Target Marking Force, and later they were converted into a separate 8th Group. A Canadian squadron from 6th Group joined them in April 1943. These 2 squadrons were the only ones operating Halifaxes within the Target Marking Force until they were re-equipped with Lancasters in August 1943 and in March 1944, respectively. The success of the target marking aircraft depended more on tactics than on equipment. However, improving bombing accuracy remained one of the most important tasks. It was achieved by 3 main methods. The first was a ground navigation aid, which required installation of special receivers on aircraft. The second was an airborne radar system installed on the aircraft and independent of ground stations. Special target indicators did not require significant modifications to the aircraft. At the beginning of 1942, 2 Halifax aircraft were assigned to the Telecommunications Research Establishment. Stationed in the English town of Herne, they were used for the first trials of an important radar system starting in April 1942. The antenna was placed in a transparent dome-shaped radome beneath the lower fuselage. At this stage of development, alternative configurations of the core device were being studied. One used a relatively well-known electronic vacuum tube, and the other employed a much more powerful but extremely secret magnetron, the detailed construction of which would have been of immense value to Germany if it had fallen into enemy hands. While discussions continued over the combat use of the magnetron within Bomber Command, the RADSYS H-2S project suffered a major setback. On the 7th of June 1942, a Halifax bomber carrying experimental magnetron equipment crashed. Everyone on board perished, including 5 leading scientists working on its development. The production of RADSYS H-2S units using magnetrons was regarded as vitally important. The first tests by a dedicated trial unit, again using a Halifax, took place in late September 1942. By mid-January 1943, the 35th Squadron had received 9 of the first production sets and fitted them to their Halifaxes. Together with the Stirlings of the 7th Squadron, this unit used the RADSYS H-2S operationally for the first time on the night of the 30th to the 31st of January, during a raid on precision targets in Hamburg. The initial results were not entirely successful because of unrefined instruments, and the full potential of the RADSYS H-2S could not be realized until the early version with a 10-inch wavelength was replaced by one operating at 4 inches. A few weeks after its introduction, Bomber Command extended its use within the Pathfinder Force, now designated as the 8th Group, and began installing it on all main force bombers except for the Lancasters configured to carry 8,000-pound bombs. This goal was almost fully achieved, and the under-fuselage RADSYS H-2S radome became a common feature of all later Halifaxes, although it was also carried by Merlin engine variants, except for those of the 35th and 405th Squadrons in Britain and the 614th in North Africa. Another important role of the Halifax, starting from late 1941, was assisting the Special Operations Executive in clandestine missions behind enemy lines. Modified to drop parachute containers through a lower hatch, Halifaxes began these missions with the 138th Special Duty Squadron on the 7th of November 1941, later joined by the 161st and 511th Squadrons. Flown mostly by Polish crews, the Halifaxes of the 138th Squadron primarily delivered supplies to Polish partisans, the Home Army. The route length exceeded 2,000 miles, with flight times reaching up to 14 hours. The Halifaxes operated at the very edge of their range. Beginning their Halifax operations in October 1942, the 161st Special Duty Squadron focused on low-altitude drops of agents and supplies over France, while in the same month, the 511th Squadron began transporting cargo in the Mediterranean. For covert operations in the Middle East, the 1575th Special Duty Flight was formed from the 161st Squadron in June 1943. In September, it was absorbed by the 624th Squadron based at Blida. In February 1943, the 148th Squadron, operating liberators in the Middle East, also received Halifaxes to support Yugoslav partisans. The 1586th Special Duty Flight, also a Polish unit, operated both Liberators and Halifaxes from Brindisi, supporting the ill-fated uprising of Polish patriots in Warsaw in August 1944. Later that same year, this unit was reorganized into the 301st Special Duty Squadron. During covert operations, Halifax bombers of the 2nd and 5th types often flew with reduced crews. Sometimes there were only 4 people on board: 2 pilots, a navigator, and a loading-unloading specialist. This was done to make room for as much cargo as possible in the bomb bay. The first missions of the 138th Squadron showed that the Halifax needed improved flight performance. In particular, it was necessary to increase speed and range to make missions to Poland more accessible and efficient in terms of payload. Soon, Handley Page modified 1 aircraft of the 2nd type from the first production series. They installed a blunt, unglazed nose with small windows instead of the usual turret and removed the upper turret altogether. The emergency fuel dump pipes were also dismantled as there were no longer any landing weight restrictions. To reduce drag, several alternative types of flame dampers were tested. A number of smaller changes further improved performance to the level of early production aircraft despite the greater weight, up to 65,000 pounds. Merlin 22 engines ran on 100-octane fuel with supercharging, producing 1,480 horsepower at an altitude of 12,250 feet. The new nose fairing was first test-flown at Radlett on August 15, 1942. It was quickly implemented first on aircraft of special duty squadrons and later on regular combat bombers. Sometimes, but not always, the upper turret was also removed from such aircraft. The nose fairings were manufactured by Tollerton Aircraft Services, so they were sometimes called Tollerton fairings. They were also known as Tempsford fairings since they were first fitted to aircraft of the 138th Squadron based at Tempsford. Another name for them was Z fairings. Officially, the modified Halifax bombers were designated as Type 2 Series 1 Special and Type 5 Series 1 Special. A more advanced attempt to improve the Halifax's performance and defensive armament followed soon after the first Type 2 Series 1 Special. The new aircraft had a more elongated nose section than the Tollerton fairing. It was made of plexiglass to improve the navigator's working conditions. A Vickers K machine gun of .303 caliber was mounted in a ball fitting there. This was combined with an upper 4-gun Bolton-Paul Type 8 turret, Merlin 20 or 22 engines in low-drag nacelles, and Morris radiators, which had a smaller frontal area than the twin-drum Halley radiators. The new nose and all the other improvements were adopted for series production as Type 2 and Type 5, Series 1A. The prototype of Series 1A, incorporating all these features, first flew on December 24, 1942. However, the first production examples retained the angular Halley radiators, officially creating the Series 1 Special designation, but had Type 8 special turrets mounted in an elevated position with fairings. This allowed the 4 Browning machine guns to fire downward at an angle of up to 10 degrees. Later, this requirement was dropped, which made it possible to lower the turret by 5 inches and remove the fairing, thereby reducing aerodynamic drag. Even more differences in defensive armament appeared when the Halifax began to be used in coastal command squadrons. This began at the end of October 1942, when the 158th and 405th Squadrons assigned part of their standard 2nd Series Halifaxes for long anti-submarine patrols in the Bay of Biscay area. A few weeks later, 2 coastal command squadrons, the 58th and the 502nd, completely switched to Halifaxes equipped with 3rd version radar and 3 fuel tanks of 276 gallons each, along with depth charges in the bomb bay. During testing, the Coastal Command Halifaxes demonstrated a flight endurance of up to 18 hours. Regular combat sorties lasted about 13 hours. One aircraft was equipped with rails for 8 rocket projectiles mounted on special racks on each side of the nose section, though this solution was not adopted for mass use. The standard armament consisted of a .5-inch machine gun in the nose with belt feed, standard upper and tail installations, 2 .5-inch guns on a turret or in an experimental remotely controlled fairing, or finally a single machine gun on a special mount. The adaptation of Halifaxes for Coastal Command was carried out by the Cunliffe Owen Company in Eastleigh. Most of these were 2nd or 5th Series aircraft built by the Roots Company, which after modification received a special index. 3 Coastal Command Squadrons also operated meteorological Halifaxes of the 2nd and 5th Series, intended for maritime weather service. These were the 517th, 518th, and Gibraltar-based 110th Squadrons. At least 7 submarines were sunk, and several more damaged by 2 Coastal Command Halifax squadrons, which were later converted to variants with new engines. The 224th Squadron in Gibraltar used the 6th Series meteorological version until March 1952. The appearance of the Halifax between 1941 and 1943 underwent some changes that have already been described. Another important change during this period concerned the vertical tail assembly. The Halifax had in fact suffered from rudder balance issues since the first flight of the prototype. This was especially noticeable at large deflections, such as those required during asymmetric engine thrust. Failure of 2 engines on one side inevitably caused airflow separation from the rudder and led to an uncontrollable spin. As an early temporary solution to this problem, rudders with rounded leading edges were introduced on the assembly line, but this created a new issue: yaw instability. Several further steps were then taken, leading to the development of tail types from A, the initial one, through G. The best solution, eventually, was Type D, created for the 3rd Series model with new engines in the spring of 1943. It featured rudders similar in outline to those used initially, with rounded leading edges limited to 2 inches and increased trim tab travel. This was combined with larger fins having 50% more area and roughly rectangular shape. This tail unit was introduced into production on the last aircraft assembled with old engines and was later fitted to 66 2nd and 5th Series Coastal Command Halifaxes and 502 Bombing Command aircraft. While the Halifax bombers of the 2nd and 5th Series in several described variants were essentially direct adaptations of the basic first model to military needs or production convenience, the Design Bureau of Handley Page considered a more fundamental improvement of their bomber. In 1939, the firm completed a project for an ideal bomber, created according to the Air Ministry specification. A full-size mock-up was built, and a prototype was planned. However, the course of the war in 1940 led to the cancellation of this program, which also included prototypes from the Bristol Company. Work on the project, which had little in common with the Halifax, was stopped. Attention was concentrated on the Halifax itself as a high-precision daytime bomber, to be fitted either with Bristol Hercules engines of the 8th Series or Rolls-Royce Merlin engines of the 60th Series. Both of these engines had 2-stage superchargers and sufficient power for operation at 30,000 feet. In practice, the Hercules of the 8th Series proved unsatisfactory, and it was planned to create an interim Halifax variant with Hercules engines in the expectation that improved high-altitude versions of the Hercules would arrive later. The Hercules engine project was given the designation Halifax 3rd Series. This development direction was chosen in 1941 by the Air Ministry, while Handley Page showed great interest in the high-altitude Merlin variant, which was designated Halifax 4th Series. For high-altitude use, Handley Page intended to increase the Halifax wingspan to 104 feet, with rounded wing tips, and to apply enlarged symmetrical vertical tail surfaces. The bomb bay was to be strengthened and modified so that when carrying bombs weighing 4,000 pounds or 8,000 pounds, the doors would close completely. For conversion to the 4th Series in early 1943, the prototype of the Halifax 2nd Series was selected, but before the first flight in March 1943, the Merlin engines of the 60th Series were not yet ready, and Merlin engines of the 20th Series were installed in the new engine nacelles. The aircraft received the name 2nd Series Modification 2. The standard wing and tail surfaces of the old pattern were retained, but the engine nacelles were lowered beneath the wing, fully corresponding to the installation on the Lancaster bomber, and the inner nacelles were lengthened so that they projected beyond the trailing edge of the wing. The latter change had previously been tested on an experimental Halifax used for aerodynamic trials of the 1st Series. New landing gear doors were introduced that completely enclosed the wheels in the retracted position. In addition, with the lengthened nacelles, 2 more 1st Series Halifaxes were used for trials. After preliminary tests at Handley Page, the Halifax 2nd Series Modification 2 was handed over to the Rolls-Royce Test Center at Hackhall, where its flight performance was measured for the first time. At an overall weight of 45,640 pounds, the 2nd Series Modification two aircraft was faster by 26 miles per hour at 25,000 feet, compared with the standard second series modification 1, which had a nose turret, a heavier mid-upper turret, and Merlin engines of the 20th series in the old nacelles. Then, the company Rolls-Royce installed on the aircraft of the second series modification 2 Merlin 65 engines. These were high-altitude engines with a two-stage, two-speed supercharger, developed for the Spitfire and Mosquito aircraft. Four-blade propellers were used, similar to those on the Wellington bomber of the 6th series. In this configuration, the prototype, which did not fully correspond to the 4th series because it lacked the extended wing and enlarged tail assembly, reached a maximum speed of 324 miles per hour at full boost pressure at an altitude of 19,200 feet, compared to the speed of 288 miles per hour at 12,400 feet with Merlin engines of the 20th series. These results demonstrated what could have been achieved had the Halifax of the 4th series entered production. By the time testing was completed in 1944, the Halifax Mark III with Hercules engines had already firmly established itself in production and began active service. This effectively halted further development of variants with Merlin engines. The Halifax Mark III became the most popular modification among all versions of this bomber. It combined the best features of the late second series versions with powerful Hercules 6 or 16 engines. Interestingly, the prototype initially had a nose section from a special variant and an upper turret of Type C. By the end of the year, a new upper turret of Type A Mark VIII was installed. And on the 1st of June, 1943, the aircraft took to the sky for the first time with a new rectangular vertical stabilizer of Type D, replacing the symmetrical Type F. In mass production, the retractable tailwheel was reintroduced. It had been almost unused on the first and second modifications. Engine cowlings similar to those used on Beaufighter aircraft were also applied. Engineers thoroughly redesigned the fuel system. The tanks that had previously been located in the forward section of the wing between the engines were moved to the center section. However, their capacity was reduced from 120 gallons to 74.5 gallons. In exchange, new tanks with a capacity of 115 gallons each were installed in the outer bomb bays within the wings. Flight tests of the Halifax Mark III revealed a problem. Ailerons with the new convex leading edge proved too heavy to operate. It was also decided to extend the wingtips, an idea originally developed for a high-altitude version of the Halifax. As a result, the wingspan increased to 104 feet 2 inches. This allowed the maximum takeoff weight to rise from 63,000 pounds to 65,000 pounds. The new wingtips were first flight tested at the end of 1943 on one of the second series aircraft. The Halifax Mark III entered serial production by February 1944. In total, only 2,063 Halifax aircraft of the Marks I, II, and V with Merlin engines were built, including prototypes. By comparison, the Halifax Mark III was produced in 2,127 units, and Mark VI and VII, 880 aircraft in total. The Halifax Mark III entered service with the 446th Squadron of the Royal Australian Air Force, part of the 4th Group, which had previously operated the Wellington. Aircraft were also delivered to the 433rd Porcupine Squadron, one of 6 Canadian units flying this type in the 6th Group. One of the oldest Halifax squadrons, the 35th, was among the first 4 units to receive the 3rd model. By July 1944, Hercules engines had completely replaced the Merlins in frontline service. By the time the war ended, at least 41 squadrons had reached operational readiness on Halifax III. This included units of Coastal Command and Transport Aviation. A few weeks after deliveries of Halifax III began, radar aiming systems H-2S were fitted to most aircraft. Most aircraft without H-2S flew with the Preston Green ventral gun installation. When Halifax II had already been well mastered in service, the Handley Page bombers played a key role in the bomber offensive. Although they were somewhat inferior to Lancaster, which could carry more bombs, Halifax remained an extremely important aircraft. In 1944, the bomber offensive reached its peak. In mid-March, the heavy raids on Berlin concluded. In 16 main raids, Halifax carried out 1,643 operational sorties. Over the next 6 months, the main efforts were concentrated on supporting the Allied expeditionary forces in preparation for D-Day and the subsequent advance through occupied Europe. Nevertheless, night raids on Germany, albeit at lower intensity, continued. On the night of 30th to 31st March 1944, during the raid on Nuremberg, pilot S. Barton earned the Victoria Cross, the only one among all Halifax crews during the entire war. By the end of the year, the Luftwaffe's ability to defend the country had fallen so much that daytime operations became commonplace. The Halifax Guerre Tour bombers began to be used in 2 squadrons of Coastal Command in February 1944. A little later, the meteorological version Met the Eend appeared. In Bomber Command, specially equipped Halifax 3rd versions served in several units of the 100th Group, which was formed in November 1943 to support bombing strikes by a variety of means of electronic warfare. These tasks included electronic reconnaissance, carried out by the 192nd Special Duties Squadron. Its aircraft, initially a few machines of the 2nd and 5th versions, carried several special receivers and a signals officer for this purpose, as well as recording equipment. Similar activities were conducted by Halifax 3rd versions in the 1,341st and 1,473rd flights. The 171st and 199th Squadrons, as well as the 1,341st Special Duties Flight, used aircraft for electronic warfare that carried the Mendrel system to jam German early warning radars. The 462nd Squadron flew Halifax 3rd versions equipped with the airborne cigar device to disrupt German radio-telephone communication channels. Several electronic warfare tasks by the 1,341st Flight were carried out from India in the last months of the war against Japan. Although the Hercules engines of the 6th version, or more often the Hercules of the 16th version, on the Halifax 3rd series worked quite satisfactorily, significant advantages could have been gained by using the Hercules 100th version. This engine used 100-octane petrol and had a carburetor of the injection type, and was also built as a fully complete power plant. To exploit the advantages of the Hercules 100th version, which required fuel delivery at high pressure, Handley Page designed a new fuel system for installation on the 3rd fuselage version with all the latest changes, including an increased wingspan. The new variant retained the designation but became known as the Halifax 6th version. Its prototype, converted from the 2nd version, made its first flight on 19 December 1943. The fuel system differed in the grouping of tanks, one group for each engine. Long-range tanks were increased in capacity, and the auxiliary tanks in the wing bomb bays, the presence of which was optional, were also enlarged. The standard internal fuel stock was increased to 2,630 gallons plus 3 auxiliary tanks of 276 gallons each in the fuselage bomb bay. The first production Halifax Mark VI took to the air at Radlett on the 10th of October 1944, but deliveries were delayed due to production setbacks with the Hercules 100 engines. In the meantime, aircraft built as the Mark VI were fitted with Hercules 16 engines like the Halifax Mark VII, and entered service in June 1944 with the 426th Squadron of No. 6 Group. Additionally, 2 Canadian squadrons, the 408th and the 432nd, also operated the Mark VII. During the final 6 months of the war, the Halifax Mark VI supplemented the Mark III in several squadrons of No. 4 Group. Moreover, this variant was intended for use by the Tiger Force against Japan in the Far East. Since the end of 1943, intensive trials of the Halifax in tropical conditions had been carried out by the 1577th Flight in India, which operated several Mark VI and Mark III aircraft. This unit was later used for transport duties and eventually for glider towing trials, in line with the Halifax's role in airborne operations. The use of the Halifax for dropping supplies and paratroopers during secret missions has already been mentioned earlier, but later the aircraft was employed for glider towing and transport on a much larger scale. For airborne operations as glider tugs and paratroop carriers, the Halifax received a special A suffix designation. These aircraft were widely used during the D-Day landings, as well as in operations in the Near and Far East. The development of such modifications began in 1942, primarily to meet the needs of the Special Operations Executive, as mentioned previously. The first 3 aircraft adapted for paratroop deployment were delivered to Tempsford to No. 138th Squadron in August 1942. The design of the Halifax itself did not allow paratroopers to be carried inside the fuselage, which is why another aircraft, and the Sterling, was more commonly used for that purpose. However, as a glider tug, the Halifax proved exceptionally useful. It was the only aircraft in the Royal Air Force capable of towing the heavy Hamilcar glider. For that reason, from the very beginning of British airborne operations, the Halifax was extensively employed for glider towing. 3 quickly modified Mark VI aircraft took part in the operation codenamed Freshman in November 1942. This was the first British airborne operation involving gliders, although it ended unsuccessfully. In February 1943, Halifax Mark VI aircraft began replacing older Whitley Mark V bombers in No. 295th Squadron. A second Halifax unit, No. 644th Squadron, was formed in 1944. In July 1943, the first long-distance glider ferry took place. Horsa-type gliders were towed from Great Britain to North Africa. Later, No. 644th Squadron operated jointly with No. 620th Squadron in the Middle East, while No. 298th Squadron used Halifaxes for the same purpose in the Far East for several months in 1945. From 1943 onward, Halifax tug aircraft took part in nearly all major operations until the end of hostilities. The first variants specifically designed for airborne forces were designated the Mark III and Mark VII airborne versions, based respectively on the Mark III and Mark VII bombers. The upper turrets were removed, a glider towing hook was installed behind the tailwheel, and the fuselage was fitted with seating for 12 paratroopers along with a special conical ventral hatch for dropping them, located just behind the wing's trailing edge. The Roots Company delivered 30 such converted Mark III airborne aircraft for temporary use, pending completion of 12 Mark VII airborne machines. The latter variant was also built by Fairey, which produced 69 units, Handley Page with 150 and English Electric with 8. A more advanced transport variant of the Halifax, the Mark VI, equipped with Hercules 16 engines, the same as on the Mark III and Mark VII paratroop versions, was designated the Mark IX paratroop version. The company Boulton Paul received a subcontract for its detailed development at the beginning of 1945. The main differences of the Mark IX were a modified interior and an improved exit door, shifted to the rear section of the fuselage. It featured panels that opened inward and upward, as well as the standard Halifax entry door on the port side of the fuselage. The aircraft could carry only 12 paratroopers, but the reinforced floor was fitted with rails for 12 cargo containers and 2 winches for hauling in parachute cords. In addition to the Boulton Paul rear turret with 2 heavy-caliber machine guns, a single gun of the same caliber was mounted in the nose section. All 3 models with the A suffix had a maximum takeoff weight of about 65,000 pounds, approximately 29,484 kilograms. The company Handley Page delivered 145 Halifax aircraft of the Mark IX paratroop version. Shortly after the end of the war, this modification replaced the Mark VII paratroop version in the 620th and 644th Squadrons, which in September 1946 were renamed the 113th and 47th respectively. One Halifax Mark IX aircraft used at Henlow Base for parachute testing and serving until 1954 became the last bomber produced by Handley Page to remain in service with the Royal Air Force. Production of the next version, which differed from the Mark IX only by its more powerful Hercules 100 engines and a total weight of about 68,000 pounds, approximately 30,845 kilograms, was never started. A second line of development led to the Halifax being used as a transport and passenger aircraft. Initially, this was done by the Royal Air Force, and after the war, by the British Overseas Airways Corporation and several other civilian companies. The Royal Air Force operated several variants converted from bombers, with all armament removed and interiors adapted for carrying cargo, 9 wounded on stretchers or 8 passengers. In addition, immediately after the war, the Handley Page Company produced 100 Halifax aircraft with improved payload capacity.